The life cycle of glass is really interesting. And one of the interesting pieces that we find is that, glass, sort of working from when it comes as raw material out of the earth, primarily sand and silica, and as it moves through the processing to land on what is most commonly used in building facades today, insulating glass units, which are multiple panes of glass with inert gas or air cavity between the two for thermal performance. And looking at the process from mining the materials, floating the glass, which is a very energy intensive process, heating the raw ingredients, and then processing the glass from applying low E coatings, laminating the glass, and then actually sealing it into an insulating glass unit. Until it ends up on your building. And then the question is, once it's reached its service life, the insulating glass unit, what happens with it? And generally, where we land today, insulating glass units often end up, unfortunately, in landfills. So one of the interesting challenges, related to glass, is this idea of reuse, the perception of reusing materials, challenge with removing low E coatings, which are microscopic layers of metal that are electronically often deposited on the glass, deconstructing the insulating glass unit, debonding laminated glass, sort of taking apart an insulating glass unit. It's not really it's not very common in our industry. And a lack of supply chain traceability, logistics associated with all of it, it just doesn't exist right now in our market here in North America. But it certainly could. And this is where we're really excited. This is where we think there could be some really great opportunities to introduce some new possibilities to say, okay, when that insulating glass unit has reached its lifespan, now how can we reintroduce that back into the glass life cycle in a way that is cost effective, that can help reduce that overall embodied carbon of this as a particular material.